Hi, this lesson's all about learning what a logarithm is. What is this thing, this log base b of y equals x? Well, the first thing that we should ask ourselves is, why do we need them? Well, logs used to be a way to multiply very large numbers, but now that we have calculators, it's like we don't need them. Or do we? You see, sure, we don't use logs for this anymore, but we do need logs whenever we're solving exponential equations. Take this interest formula. Do you know how to solve for t, to get t by itself? Well, we'll need logs in order to do that. Let's start with the formal definition of a log. Suppose that b is bigger than 0, so it's positive, and it's not equal to 1. Then there's a number x such that the log base b of y equals x, if and only if b to the x equals y. Now, of course, mathematician understands what that means, but let me see if I can break it down a little bit more. You see, the power of this definition is that we can rewrite logs as exponentials, and vice versa. So let's practice that. All right, so here in our first example, we have 2 cubed equals 8. Well, notice 2 is the base of the exponent, and it's right in the same place as b. Right, so this b becomes the base of the log. So this is log base 2. And then we notice, okay, this x gets moved on the other side of the equal sign, and it's log base b of y equals x. So log base 2 of 8 equals 3. Some people will just refer to this as a loop. Log base 2 of 8 equals 3. And you can go the other way around. See, log base b of y equals x, or b to the x equals y. So go ahead and try that on part B. All right, hopefully you got log base 16 of 4 equals 1/2. Just by going log base 16 of 4 equals 1/2. All right, so now let's see if we can go the other way. Here these are in the form log base b of y equals x. And we're going to say, okay, we need it to be b to the x equals y. So 2 to the negative 3 equals 1/8. 2 to the negative third power is 1/8. And that's true, and we know that. So you try part B. All right, and you should have gotten 27 to the 1/3 equals 3, which is just saying 27, take the cube root, and that's 3. So this is true. All right. All right, now let's use that skill to evaluate logarithms. See, these don't actually say equals anything, but we can act like they do. We can say, okay, I'm going to imagine that there's an x here. So 4 to what power equals 64? Well, that would be 4 cubed. So log base 4 of 64 equals 3. All right, let's do it again. 5 to what power is a fifth? Well, that just sent 5 to the denominator, so that must have been 5 to the negative first power. And again, this is just because, here's a little thought bubble, 5 to the negative first power is a fifth. All right, you try the last two. All right, hopefully what you got here was negative 3 and 1/2. Because 5 cubed is 125, so 1/5 to the negative 3 would equal 125. So again, that's because 1/5 to the negative third power equals 125. And over here, raising something to the half power, so 36 to the 1/2, that's the same thing as taking a square root, so that one works as well. All right, the last thing I'd like to talk to you about are special logarithms. And these are logarithms where they're used so often that we don't always have to write the base. The first up is a common log. This has a base of 10. So log base 10, we can just write log. If you just see the word log, you assume that its base is 10. So the log of 100 would equal what? Well, we think to ourselves, okay, this must be base 10. 10 to what power equals 100? Oh, that's 2. So common logs have a base of 10. Natural logs have a base of e, which is called the natural base. These are represented like this. So instead of writing log base e, we just write ln. That stands for natural log. This is one of the most used logarithms for the rest of mathematics. So just memorize that a log base e is a natural log. All right, and that's the introduction to logarithms. Goodbye.